This video is on the objective solve trigonometric equations using a calculator. And now these will be trigonometric equations that are linear, right? So you're only going to see one trig function to the first power here, and it'll be similar to previous linear trigonometric functions and equations. You get that trigonometric function on its own, right? Isolate it on its own side. But then the number on the other side this time isn't going to be so nice. So we'll have to use a calculator to find, one solution, and then using that one solution we can derive all the other infinitely many solutions. And then we'll also then have to wheedle it down to, the solutions that they want, that are between 0 and 2 pi, in a particular range. Alright, so if you want to see more instruction on this, more about what they have to say about it, click on More Instruction and look at their videos, their notes, their examples, and hopefully those help you. Alright, so we're asked to solve the following equation for theta, but they only want the values of theta that make this, a true equation, a true statement. They only want the values of theta between 0 radians and 2 pi radians, including 0 but not including 2 pi. Alright, so we have a linear equation here in cosecant. Right, so I'm going to write this out and we'll work on it. Let me get rid of the calculator for now. Right, we'll bring it back up in a second. So we have the equation 3 times the cosecant of theta plus 5 equals 0. Now if I solve for cosecant theta, we'd have cosecant theta equals negative 5/3. Right, I would subtract 5, then divide by 3. Now negative 5/3 is not a nice number, that you should know. It's not a number related to any special angle like 30, pi over 6, pi over 4, pi over 3, anything like that. Right? It's not 2 or negative 2. It's not 1 or negative 1. It's not square root of 2 or negative square root of 2 or 2 root 3 over 3, stuff like that. So this number is not not a nice number when we're talking cosecant. So that means we're going to have to use a calculator to help us out. All right. Now, on the calculator, this is a cosecant of theta equals negative 5/3. There's no inverse cosecant. Right? Remember, there's inverse sine above the sine, there's inverse cosine above the cosine button, there's inverse tangent above the tangent button. But there's no inverse cosecant. So, what I'm going to do is, since I'm going to be using the calculator, and there's no, like I said, there's no inverse cosecant function on the calculator. Right. I'm going to change this then to a sine equation by taking reciprocals. Alright, so I make this into a sine equation. We'll just take the reciprocal of both sides. Alright, and the reciprocal of cosecant is the sine of theta. And the reciprocal of this is negative 3/5, right? Or negative 0.6 if you want to write it as a decimal. Alright, and then I'll work with this one. Alright. So the first solution I can find with the calculator is the inverse sine of negative 0.6. Alright. So one solution we can get from this, and only one. There will be infinitely many, but we're going to find one to start with. So one solution of this equation would be theta equals, the inverse sine of negative 0.6, right, which all my options in the book on the web page in the homework are rounded to 3 decimal places. So let me do that here. So I'm in radian mode, right? You know, they gave us the range from 0 to 2 pi, so they're going to want answers in radians. So make sure you're in radians. And the inverse sine of negative 3/5, negative 0.6, is, you know, approximately negative 0.644 radians, right? Remember, this is an angle measure. Remember, all the inverse trig functions result in angle measures. And I'll draw this along with a unit circle. A very tiny one, but remember, unit circle is just a circle with a radius of 1 centered at the origin. And this angle here, you know, negative, if you want, you can multiply by, you know, 180 over pi if you want in degrees. But negative, you know, that's about negative 37 degrees. All right. But I'm going to keep it as radians, though. I'm just showing you, if you want to change it to degrees, it's easy. So here, right, that's again, you always start at the positive x-axis when drawing angles in standard position. And we're talking this angle here in quadrant 4. There's, you know, negative 0.644 radians. Right? And remember what it does. You know, when we draw an angle along with the unit circle, wherever that angle ends, right, the point on the unit circle, the x-coordinate is the cosine of that angle. Right, so the cosine of this angle would be whatever the x-coordinate of this point is. The sine, though, is the y-coordinate. And we know from this line that the sine of this angle, this negative 0.644 radians, the sine of this angle is negative 0.6. So the y-coordinate here is negative 0.6. So I'll mark off negative 0.6 on the y-axis. Okay. And you can double check that, you know, what is the sine of negative 0.64? Now this is a rounded measure, negative 0.644, and you're seeing it's negative 0.6 basically. All right. Because again, the only reason this is off is because it's rounded. But yeah, so the sine of negative 0.644 is negative 0.6. But you see, that's not the only point. That is not the only point on the unit circle here that has a y-coordinate of negative 0.6. There's also this point over here. All right, this point on the unit circle also has a y-coordinate of negative 0.06. So I want to figure out what this angle is then. So if I start from the positive x-axis, what is this angle, you know, that takes me to that point? And I'll do a positive angle this time. Now, we know that this much, right, if you go halfway around, I go from here to here, that's pi radians. All right, remember, halfway around is pi. And then what's left should have the same measure, but positive as this measure over here. All right, so what's left, you know, this measure would be positive 0.644 approximately. All right. Or the opposite of this inverse sine. All right. So our solutions, right, and I'm going to write out the general solution, you know, a description of all of them. So the general solution to this equation one of these branches will be this, you know, theta equals the inverse sine of negative 0.6, right? That was this angle here. And that obviously has a sign of negative 0.6. And then I could add to that any multiple of 2 pi. Right, 2 pi times, add 2 pi times k. Add 2 pi, subtract 2 pi, you're back at the same spot. And this is where k is an integer. Or, right, theta could be, this other angle, right, which is pi plus 0.644, which is pi minus, right, because this positive 0.644 is the opposite of this inverse sign. So I could take pi minus the inverse sign of negative 0.6, take that angle, and then keep adding 2 pi or subtracting 2 pi, right? Add multiples of 2 pi. Right? So plus 2 pi k, where k is an integer. Okay, so here, again, is a general description of all infinitely many solutions to this equation. And then I'll go off and start listing some. Right? So here's a list of some of these solutions. So one of them is about negative 0.644, and the other one here would be pi minus that. So pi minus the inverse sign of negative 0.6. So about 3.785. And then what I'm going to do is just take these two angles here and then keep this way I'll just keep adding 2 pi. This way I'd just keep subtracting 2 pi, right? That's all I mean by the adding 2 pi k. So if I take negative 0.644, negative 0.644, and just add 2 pi, I'd get another solution. About 5.639. So 5.639 would be another solution. And again, I can just keep adding 2 pi, get all sorts of solutions that way. Keep subtracting 2 pi, get all sorts of solutions that way. Same thing for the 3.785, right? 3.785. Add 2 pi, subtract 2 pi, just keep doing that. So I get, another solution would be approximately 10.068. And again, I just keep adding 2 pi and keep subtracting 2 pi this way. So right now I've shown you here are 4 solutions to this equation. Right. But, they don't want 4 solutions. They don't want all of them. They want the solutions that range from 0 to 2 pi. Remember, 2 pi is approximately 6.28 radians, right? So what are the values of theta that solve the equation but are also just in this range? And those are these values here, right? 3.785 is in here, 5.639 is in here, and then all the ones after that. If I keep adding 2 pi, see, these are going to be too big. And if I keep subtracting 2 pi, subtracting about 6.28, all these other solutions will be negative, so they'll be too small. All right, so the only solutions that actually fit the bill, right, that actually fit in this interval are 3.785 and 5.639, rounded to 2 decimal places. And let's check those out. Now, I already showed you the 3.785, right? No, I didn't. I did negative 6.64. So let's see if it satisfies this equation. Let's go all the way back to here with the cosecant. Just do the sine one. It's the same thing. So is the sine of these two angles equal to negative 0.6? Now again, it'll be round. These are rounded, so it'll be about negative 0.6. So let's see. What's the sine of 3.785 radians? And hopefully it's around. Yeah, see, that's basically negative 0.6. Negative 0.59999, right? Then how about 5.639? What's the sine of 5.639 radians? And look, negative 0.60, that's negative 0.6, right? Again, this was a rounded value, so the answer is going to be a little off, negative 0.6, but it's basically negative 0.6. So these are good solutions, rounded to 3 decimal places. So back here, 3.785 was one of them. And now I said 5.639. They must have kept it rounded the whole time, and they got 5.640. That's basically 5.639 here, right? So these are the two closest to the actual solutions of this equation in this range, right, from 0 to 2 pi. Wonderful. All right, so again, a little tricky these, all right, but still doable, right? And if it helps, draw some pictures of a unit circle and point out where certain angles have to be. These two had to be in quadrant 4 and 3 in order for the sign to be negative. Right? If you're talking cosine, where's the cosine negative? That would be in quadrants 2 and 3, and so on. You just got to pay attention to the trig function you're working with. And also remember that there's only an inverse sine, an inverse cosine, and an inverse tangent function on your calculators. So if you're given an equation with secant, cosecant, or cotangent, and the numbers don't come up real nice, you need to use the calculator. Take the reciprocals, right? Look at the reciprocals so that way you can actually use one of the functions, one of the features on your calculator. All right, and hopefully watching me do this, looking at more instruction in the homework, looking at the answer explanations, hopefully all this stuff helps you when you're doing these on your own. And thanks for watching.